In our previous videos, we've done simple subqueries. And when I say simple subqueries, we mean that the subquery runs and gets a result or some results, and then those results are used in the outer query. Now we're going to talk about something called a correlated subquery. And I'm not going to have you do any of these. At this stage in your career, I want you to understand what a correlated subquery is. I find that if it's something that involves that you need to use a correlated subquery, it's usually easier for most people to write it as a join. So let's look at an example. I'm just going to show you an example. So here's the question we're trying to answer. Which salesperson has an order with the total due that's more than $150,000? Okay. So if we were doing that with a join, we'd take the business entity ID, the first name and the last name from the person.person table, joined with the sales order table, where the business entity ID equals the salesperson's ID, okay, where the total due is greater than $150,000. That's actually a pretty easy query to write. Let's look at the same thing using a subquery. I'm going to show you the subquery that does the exact same results. And same results. So let's run it to prove it. There's the original results. Here's the same results using the subquery. What's different? We're still getting the business entity ID, first name and last name, concatenating those together under the word name for the person. We're getting it from the person.person table, and then we're doing this exists. So remember, I told you before, if you're looking for the existence of data, it's almost always better to do a join. It's way more efficient on the server. But what are we looking at here? We're getting the salesperson ID from the sales order header, where the total due is greater than $150,000, and the business entity ID equals the salesperson's ID. Right? What's different about this from what we saw in our last videos? In every other video, our subquery runs first, and then the results are used in the outside query. But let's take a look down here at our condition, at this condition. Okay. You can see that our subquery is actually using P, which is from the outside query. Okay. It's not just using the table from the inside query, from the inner query. All right. So anytime we're using something from the outside query in the inner query, it runs differently. It doesn't do the subquery and then do the outside query. What happens is the first line of the outside query runs, then it does the inside query to see if it matches. Then it goes and does the next line of the outside query. Then it does the inside query to see if it matches. Then it goes and gets the third line from the outside query, and it looks to see if the inside query matches. So in a simple query, inside query runs once, outside query runs once, and we're done. In a correlated subquery, where you're using something from the outside table on the inner query, this inner query runs once for every row in the outside query. So if I have 19,000 people in my database, which we do, it's going to go through each one of those people and run the inside query once for every person. That puts a huge load on the server. In that case, correlated subquery is way less efficient than what we did up here with a join. All right. So I'm not going to ask you to write any correlated subqueries. Most of the ones I would have you write would be way easier as a join anyway. What I do want you to know is how to recognize a correlated subquery. Know that it's running, know that it's inefficient, and know that the best way to fix it, if you can, it's better usually to write it as a join, especially if you're using that word exists. So how do you tell for sure? You look and see if you're using a piece of data from the outside query on the inside query, then you're doing a correlated subquery.